Hi everyone, I'm Almin Thron, Sales Engineer with Techmatic, and welcome to our webinar today on accurate dosing systems. Sharing their experience and insights with us today, we have guest speakers from Cheng Process Africa and Volumetric. Today we will be discussing dosing systems in more details, and we'll cover key points like the different types of dosing systems, how the accuracy of loss and weight systems is determined, and the process considerations during the design of dosing systems. Our moderator for today's event is Karsten Wodrich. He has a master's degree in engineering and has designed specialized pneumatic conveying systems for various industries in the past 21 years. Karsten is the Group CEO at Techmatic Engineering and is responsible for the engineering of dry powdered and granular materials handling systems. Techmatic is a specialized supplier of turnkey systems to convey, process, and store a wide variety of bulk material. We acknowledge each client's unique process requirements and custom design the system accordingly. We are happy to assist you, and if you have any challenges or questions, follow the link in the chat to set up a one-on-one conversation with one of the experts. We are privileged to be joined by engineering and business leaders worldwide, with attendees joining from South Africa, Zambia, Tanzania, DRC, Canada, Germany, and other parts of Africa. To have a better view of the webinar, kindly switch on speaker view by clicking on the view button on the top right-hand corner of your screen. We encourage you to join in on the conversation by posting your questions in the message chat. Please direct all questions directly to Karsten. We are also joined by our special guest speakers, Japie and Greg. Greg Krause joined Volumetric in 2007 in the drawing office, and from there quickly progressed to design engineer in 2015. He has a diploma in mechanical engineering and is presently the managing director at Volumetric Solids Machinery. Greg is driven by his passion for design and is an analytical thinker. He has more than 10 years of experience in various materials handling equipment. Our special guest speaker joining us today on weighing technology is Japie Joubert. Japie Joubert joined Cheng Process Africa in 1996 and has a national diploma in light current. He started as a service technician and moved into projects as a project engineer shortly thereafter. He currently holds the position of sales manager for Cheng Process Africa. Japie has more than 26 years of practical on-the-job experience in various weighing and feeding applications. He has a technical design hand in all applications, leaving the factory floor to customers. Karsten, thank you so much for joining us today. I'll hand the platform over to you from here.
Great. Thank you, Elmi, for the introduction. And I think I just briefly need to explain the synergy between the two companies. Volumetric basically manufactures granular and powdered materials feeding equipment, like, for example, rotary feeders and screw conveyors, while Cheng Process have a considerable amount of expertise in the mass measuring and mass control fields. So both can sell their products individually, but in the end, it's about creating solutions to make your processes work. So by combining the two, you take the volumetric feed equipment together with the state-of-the-art weighing technology, and you create accurate gravimetric dosing systems. So I think let's run straight into some of the questions that I think a lot of attendees would like answered. So let's just do a general one for now. From an overall perspective, process perspective, how does the process design influence the accuracy of a dosing system? And I think, Greg, if you can start with that, and Japie, after Greg's answer that, you can maybe just add your thoughts as well.
Oh, thank you, Karsten, for the question, and yeah, thank you very much for having us. It's a privilege and an honor to be here, and yeah, hopefully we can get through it. So, on an overall perspective, a process perspective, insights into a customer's process can definitely help us better understand which system would best suit the customer's needs and what they would actually expect out of it. A customer may only require a system that needs to feed a conveyor belt where at a steady rate, where there's like about a 5% or 10% allowance in accuracy, which they might find acceptable. And on the other hand, you might have a customer that requires very fine dosing where maybe a two-stage feeding system may be required. Then second to this is positively identifying what the customer's actual products are. Is it a sticky, lumpy product, or is it a free flowing? And after understanding this is what kind of drives equipment selection and actual hopper designs that we are obviously able to bring together and best select for that process and help with that accurate selection.
If I may add some information, thanks guys for having us on this webinar. Some of the information that is also relevant from the customer side to understand the overall flow is what is the equipment feeding this dosing system? Is it an air slide, or is it a conveyor? Is it a bin just with mass flow? And even sometimes a lot of the equipment behind the dosing system. Does it feed into a kiln? Does it feed into a mill? All that sort of information is quite relevant in selecting the right equipment and specifying the right equipment so that the accuracy that the customer needs is actually achieved. So understanding the customer's process overall plays a big key in selecting the right equipment.
Great, thanks, Japie. That's a great insight into that. Greg, how would you typically select the feed equipment for a dosing system? And I think you've alluded to it to a certain extent in the first question already, but any more detail on that?
Thanks, Karsten. Yeah, as said before, understanding the actual process of the process and understanding the material helps us best select a piece of equipment for that job. And I think one of our strengths on Bulkmatic side is, even though we have standard equipment, is we're also able to modify our standard equipment to best suit the customer's requirements. An example of this is conveying coal versus filter cake, for instance. I mean, we've got a selection of screws, but we're able to quickly convert from a single screw with hardened flights, and on the filter cake side, we might require a twin screw auger, which better helps with flowing of that material and minimize buildup. So to add to that, we've also got a full test rig set up at our factory here, which we're able to test the products and best select that product for that application.
Great, thanks, Greg. Japie, could you just elaborate on the different types of dosing systems? Because I believe that's not just a single dosing system that you get. There's various ways of doing it. And Greg, if you can maybe just add to something to that afterwards.
Yes, interesting question, which gets asked a lot of the times. The most basic dosing system that you would get, and the most popular is probably a wave feeder, where it's a belt with control on it that you feed material into a system. And then there is a loss and weight feeder. You can have a batching system, even a simple thing as a belt wire, where you just feeding material on a belt can be seen as a dosing system as well. And then there's the more complicated ones like a train loader or systems like that. That's about the basic dosing systems that you would get.
And I think just to add on to that, I think with Japie's technology in terms of the Cheng side, we typically, like Japie was talking about, it's the loss and weight system. You have the hopper with the actual hopper on load cells with the screw or vibrating tray feeding. And I think with that advancement of technology, you can have it the other way around, where you have a static hopper, static hopper that's tied to a loss and weight belt feeder further down the system. And with PID control, we're able to control the screws further upstream. So, there's a lot of different ways to look at it these days. And yeah, speaking to Japie and myself, we're able to look at that and obviously choose the best system.
Great, thanks. Japie, we mentioned gravimetric feeding and volumetric feeding in the beginning when I did the introduction. Can you just explain what the difference is between the two?
Yes, the differences, and it's something that confuses a lot of people when we start talking about gravimetric and volumetric. The easiest one, volumetric, it's basically you feed according to volume. So normally you do not weigh any of the material. it's purely you feed by volume. So if you take like a normal auger or a belt weigher, something like that, that's pure volumetric. You don't really weigh what you're feeding. Where versus gravimetric feeding is you actually weigh the material and you control according to what you weigh, control the material feeding into the system. So a quick analysis between the two: volumetric, no weighing, no control; gravimetric, control, and there is weighing involved. Basics.
Right. Okay.
I can talk forever on the subject.
Great. Okay. Then one of the questions that's come through when we had the original webinar is how is the accuracy of a loss and weight feeder determined in the end? Japie, if you can maybe just elaborate on that.
Yes, a loss and weight feeder, the accuracy of that is determined because you've a traditional loss and weight feeder is a bin sitting on load cells, so it's a static system. There's no moving parts. So your only moving part is either your feed element, which can be an auger, a screw, a feed belt, vibrating tray feeder, anything like that. So to calibrate it, you actually want to calibrate the bin. So the more accurate you calibrate your bin, the more accurate your system is going to be. Because the principle of a loss and weight feeder is it's losing material weight over a specific time. So the moment you've got your weight calibrated properly, you will have a very accurate system. And obviously, the longer you run a loss and weight system, the more accurate it gets. It's not an instantaneous accuracy, it's a time-based system because we are losing material over a specific time. And that's the principle of it.
Great. Okay, super. Thanks for that. If we look at a range of feed rates required in some applications, and you often have a customer that comes in and says, I want a 0 to 100% feed rate. Japie, how would you design the system to accommodate those customer requirements?
Yes, that's probably something that Greg can answer as well, so he can fall in behind me here. But you need to look at, normally there is a limit that a motor can run at. A motor does not have infinite range that you can run at. So normally when you start running very slow on a motor, it starts jerking and then you get you lose the accuracy and you lose control of the motor. So in essence, we try to say at 10% minimum of the overall feed rate. So if it's a 10 ton per hour feeder, 1 ton would be the minimum. So that's the normal ranges that we try to stick to. It's not always that practical, but we try to stick to that values. And I'm sure Greg can add on to this quite a bit.
Yeah, I think when we're specifically looking at screw conveyors, generally it's a 1 to 6 turn down ratio, but with the advancement of technology these days in your VSDs and in your motors, we're able to obviously achieve better turn down ratios of that 1 to 10, like Japie was talking about. It's one of the things that we work together to make sure we get the accuracy that the customer requires at the end of the day. But yeah, we look at different things such as bin designs, actual feeding into that piece of equipment, and yeah, we better look at increasing that turn down ratio.
Can I just add something on top of that? In terms of using the motors, with the new technology that Greg has mentioned, there's something like a servo motor, where you can also control a lot better your bottom end of your feed without losing torque or anything like that. So that gives us a better range of feed accuracies and the dosing speeds. But it depends on the requirement from the customer. It's not always required that you need to go to that elaborate type of system.
Great. And then I assume, Japie, maybe you can just answer that quickly, is that if you really need to go to the very lower ends and you can't accommodate that on your normal system, that you actually go to a twin dosing system where you have a much smaller system on the side to
Yes.
do the very low feed rates.
Yeah. Normally in a system like that is you run a dual system with a dual auger that you, for the low feed rates, you would preferably then run one of the augers. And the moment you go over a certain range, the second auger would kick in automatically to run the top end of the feed rate.
Okay, great, 100%. Greg, in terms of designing volumetric feeders, I mean, most of the feeders, like for instance, a rotary feeder and even a screw feeder, do give you a pulsing flow. How do you generally design a piece of equipment to minimize that pulsing flow?
Well, great question, Karsten, thank you. I think over the years, and we've had a lot of experience on this, and it's taught us a lot. And with that comes that understanding of product properties and how it actually reacts with different types of feeders. Over the years, we've designed specialized pieces of equipment to suit the app or different applications. Examples might be specialized screws, where we look at the actual size of the pocket and that pocket to actual rotational speed, so that we don't have a massive pulse. And we look at actual flight designs and look at twin flight designs, etc., on the actual screw itself. Otherwise, we might look at tray feeders, or at another application might be a rotary vane feeders, where we use a spiral impeller, and yeah, we take into account the product obviously and the speed at which we run those different pieces of equipment to ensure that we don't get those pulses. Obviously, if we run the equipment a bit slower as well, we increase the life of those pieces of equipment. So we take a look at it all, and yeah, we try to select the right piece of equipment to minimize that pulse.
Okay, great. Japie, here's one for you. In terms of performance guarantees, those are normally the requirements by clients. What sort of performance guarantee can you give on feed rates on a typical dosing system in terms of the accuracy?
In terms of accuracy, the guarantees that we would normally give is 0.5% accuracy. That is sort of a standard. In a lot of cases, we can achieve a lot better, but that's really special cases. But we would not really go better than 0.5%. That's more or less the standard in the industry. Unless you go for an assize system, then obviously your NRCS regulations and things comes into play, and then you have to achieve certain accuracies. But as a normal 0.5% accuracy.
Right. Okay. 100%. We alluded to it earlier in terms of vibrating feeders under typical loss and weight systems or so. And I think Japie, you might be able to answer this one. Is how do vibrations influence the dosing system, and how would you typically deal with that type of thing?
Okay. Vibration, yes. If you put a vibrating tray underneath a loss and weight feeder, you generate some vibration in the system, obviously, and that falls back onto the load cell. Now, the electronics that we use has got special software in it, a special program that you can monitor that vibration, and you can eliminate that effect of that vibration on the accuracy. And so as well, then, if there is vibration in the plant, if it is a normal standard range of vibrations, you can, as long as you can record it and it is more or less stable, you can accommodate for that in the software, where you basically then eliminate the vibration on the system.
Great. Okay. And if you've got multiple frequencies, is that something you could deal with as well?
Yeah, multiple frequencies becomes a problem. Because you can't really always measure the differences between the multiple frequencies, and you can't predict where they happen. So normally, if the vibration is a relatively standard, where there's a motor starting up and it continues to run and it causes a vibration on the structure or something like that, you can eliminate that. But the moment you have got funny vibrations that come through in peaks and spikes and all sorts of things, you can eliminate it to a certain degree, but not completely, unfortunately.
Okay, great, 100%. Japie, we also have the question of in-flight material very often. For instance, if you're feeding into a loss and weight system, you've got product coming down the chute. How would a dosing system typically deal with that? Because I would assume it would affect the accuracy if you don't take it into account.
Yes, your in-flight material is a big issue in a lot of cases. Now, what we normally do is, there's limits where we would fill the bin, because the loss and weight bin, you need to fill it to a certain level. So we leave enough space in the bin for the the Inflight material to get into the bin so that you've got enough space in the bin in the first place. And then we always put a delay on the switching over from the volumetric side to the gravimetric side of the system, so that there is a little bit of settle time where the material still can get into the bin, settle down before it switches back to gravimetric mode, and you actually take control of the feed again to run that. So there's some special software in the electronics that caters for all that.
Okay, great, thanks. Another question here is, what sort of consideration need to be taken into account when you determine the number of load cells used in a system? Because, I mean, obviously, if you're looking at massive big silos, for instance, that you're feeding out of, you could have an eight-legged silo. How do you generally do that? And what is the sort of ideal number of load cells on a system?
Yes, ideally, you would try to stick to 3 legs on a system, meaning three load cells then. Because the moment you start balancing something on 3 legs, it automatically balances on all 3 legs. 4 legs can sometimes be an issue where it starts to rock on two legs. But in a lot of cases, it is not practical to only put 4 legs or 3 legs on a bin where you've got 2,000 tons of material or thereabouts. And then you have to have more legs structurally to hold the system up. Now, in that case, we would use a special cornering board where you can balance the load cells, or you can put normal shims in it where you can measure each load cell individually and then shim the load cell to make sure that all 4 or all 8 legs or whatever amount of legs you've got on the system actually sits properly with the weight, that the weight is balanced on all 8 legs.
Great. Okay, that answers that one. It's typical like the bar stool with the 3 legs that stands nice and stable, whereas a 4-legged one doesn't.
Yeah, exactly. Right.
Yes. Then just a question in terms of the smallest feed rates that one can achieve in a dosing system. Can you maybe just elaborate what you've managed to do on your side in terms of minimum feed rates and maximum feed rates?
Minimum feed rates, 20 grams per hour. Is sort of the norm in the pharmaceutical industry. And then going to the bigger systems, 20,000 tons an hour on train loaders. So it's a big range with a myriad of instruments and equipment and things between it.
Great, yeah, that's quite a big span there. Okay. Greg, one for you. In terms of difficult materials and low dosing rate requirements, how do you prevent bridging? Because obviously the opening size is something that determines when a material bridges. How do you generally deal with that type of thing?
Well, we can look at designs in the hoppers. We can integrate paddle stirrers above the actual dosing screws themselves. Look at flexible bin wall designs with actual massages to massage that material. We can look at rotating vertical screws to help bring that material to the center, not to mention live bottom screws. So it's multiple screws along the floor of a flat bottom type of hopper, and we bring it all to the center and then screw it out. Also looking at Teflon coating or some of the new advanced plastic coatings just to help with that actual, or aid in that flow of material out of that hopper.
Okay, great. Because I think that's one of the big challenges on small feed rates in the end. Let's just have Greg, from your side, have a look at the bin size to output feed. How do you balance the cost and accuracy of something like that in terms of the process?
So I think it's a good question, and I think it's been a bit discussed a bit earlier. One needs to look at that actual process and actually look at and find that balance between what the customer requires in accuracy and select the hopper from there. It's just not practical sometimes to do a loss and weight system from a 100-ton storage hopper, and you're needing a very small accuracy of, say, 5 kilograms or within 1 kilogram. I'm sure Japie can add to that after this, but there's a 0.02%, I think Japie was saying, in terms of the accuracy on a load cell. And if you're trying to get a very fine accuracy of a 100-ton silo and you're doing a loss and weight system, you're just never going to achieve it. So, it's that balance and trying to save the customer money at the end of the day. You look at that process and find out what he actually requires. Is he filling a bulk bag and needs that 1 kilogram, or is he filling a storage silo where he doesn't need that 1 kilogram accuracy? And I think also determining that amount of filling cycles in an hour, in an hour or in a day, can help us better determine that actual loss and weight system that he may require. Japie, I don't know if you want to add to that.
Yes, if I can add to that just briefly, normally we try to stick to a rule of thumb where we say the feed rate required, the maximum feed rate required on a loss and weight feeder, the in-feed should be 10 times that feed rate. So if the loss and weight feeder is a 10 ton per hour feed rate, it theoretically means that you need to fill it at 100 tons an hour. So you need to select your system carefully that you don't make it too elaborate or too costly, that your in-feed is actually cost more than your loss and weight feeder. So you need to determine nicely what your requirement is before you do anything about it.
Yeah, that makes full sense. Here's an interesting one that we've come across quite often as well is, why do I need a Cheng weight controller? Can't I just use the plant PLC or the DCS to control my dosing equipment? And Japie, you'll most probably be able to answer that one.
Yes, the using a DCS system, yes, or a PLC, you can do that. It has been done in the past, but it is not very successful for the mere fact that a PLC or a DCS system is looking holistically at the whole plant. It is not paying attention to the small detail of a wave feeder, where the Cheng electronics, which is dedicated for a wave feeder, pays constant attention to that specific wave feeder or loss and weight feeder or dosing system. So if there is something small that happens to it, it can react immediately to it, correct it, and in a lot of cases, you would not even notice that something happened. But where a PLC controls the system, there's a cycle time in the PLC, or the PLC is busy somewhere else. There's time that can happen. Time goes by, and the system can go completely haywire and cause bigger problems. And for that reason, we try to recommend that use a dedicated system that dedicates all its attention to one system, to one feeder, to control it, where the PLC then just gives a start-stop feed rate, and we give back a actual feed rate and some other signals if required.
Oh, great, that makes full sense, because there's often the question, can I save money by just using my DCS or my PLC? And what you've just answered now makes full sense, to actually have a dedicated system there. Japie, under what conditions would you use what type of controller? I mean, I know that Cheng Process has quite a few controllers available. How would you select that?
The controller is dependent on how the customer operates his plant. A lot of cases, we've got electronics that is got a display on it, so the operator or the person in the plant can see where the unit is. There is a display. We have got blind instruments where there's no display. All the information is either sent by hardwired or by communication protocol, Profibus, Modbus, DeviceNet, Ethernet, like that, to a PLC. So everything is displayed in a central place. So it really depends on what requirements the customer have, where we then select which type of instrument we're using. So the Intercon Tersis has got a display. It's a small standalone unit. The Discon Tersis is a bigger unit, but it's a blind unit. You can add a display to it, and you can expand it. It's not really limitless, but you can expand it quite large. And then the newer range of electronics that has basically just been released, the conic measure, is the new range that we've got, where you can have it as a blind unit or with a display as well.
Great. Okay, thanks for that, Japie. And then I think we're sort of running to the end of the webinar here. I've got a question for each of you. And I think it's an important question. Yeah, I think Japie, let's start with you. What sets Cheng Process apart from other suppliers of weighing systems? Because that's always a question that a customer would typically ask as well.
Yes, and it's not an easy thing to answer, but keeping in mind that Cheng Process has been in existence since 1881. It's a very old company that has spent millions every year on development, expanding the brand, getting new ways of doing things. Our R&D budget is very big. We spend a lot of money on getting the latest technology. It is the Rolls-Royce of equipment, and Cheng Process is a German company, so the Rolls-Royce is actually probably the wrong one. We should say Mercedes or a BMW range of equipment. So it is the best. It's pricey, but the quality that you get is a Mercedes or a BMW versus a Toyota. Some people is going to be upset about that statement now.
Great, thanks, Japie. I think that answers that question. Greg, and then the same question to you. I mean, many companies manufacture, for instance, dosing screws. So what sets Volumetric apart from the others?
Well, I think pretty much, anybody can design or anybody can manufacture a dosing screw. But, at the end of the day, our customers are not just buying our manufactured dosing screw. They're buying our actual history in terms of our understanding of the process. So, we're looking at the process from start to finish. We go beyond just the inlet flange and the outlet flange of that dosing screw. We're looking at the full process, and the customer is actually buying our product history and knowledge in bulk handling equipment. And we can obviously advise the customers accordingly, and hopefully give them that best support at the end of the day once we've actually supplied the product. And then, if there's any issues on site, we're able to assist quickly and resolve that solution. So it's not just an off-the-shelf item where you're phoning a call center and getting a tone. We're actually there to assist and adapt under different conditions.
Great. I think that answers the question there. I mean, I think we're sort of getting to the end of the process. Can I hand back to you for some closing remarks?
Yes, perfect. Thank you so much, Karsten. So just from our side, thank you, Karsten, Greg, and Japie, for the information that you shared with us today and the time that you offered to be with us again. I think we can all agree that the insight shared is of great value, and I trust there are some very valuable key points that we are all working away with today. So just some of the key points that I gathered from my side is that there's so many important factors to consider when looking at dosing systems. And one of those is the required accuracy, but also the overall process design. It's the combination of the quality volumetric feed equipment and the state-of-the-art weighing technology that provides the accurate gravimetric dosing system. So it's important to note that the decision made is based on the experience that the supplier or the design engineer has with that product. So as mentioned before, we are here to assist. So if you have any specific challenges or issues on site, we would like to offer an assessment on the process or system whereafter we can submit. If this is of interest to you, please use the link to schedule some time with one of our experts. So that pretty much is everything from our side. So I just want to thank everybody for joining us today.
Thank you for having us. Appreciate it.
Great. Thank you very much.
Thanks, everybody.